Hi everyone, welcome back to the channel. In this video, we will go through a case of calculating a volume of a pit like this and a small hill like this below and above a specified base level. Now I'm going to spend relatively a bit more time explaining the methods and tools for this for the case of the pit. And once you have properly understood the concept, it just becomes a matter of performing the same steps for the hill to calculate its volume when it comes to that. So before we get started, let's have a look at the datasets that we are going to deal with today. And right over here, you can see two rasters. One is called pit.tiff and the other one is called hill.tiff. So it's pretty self-explanatory which raster dataset refers to what. So what I'm going to do is I'm just going to drag this pit.tiff raster onto my workspace like this. And as you can see over here, this is the default color ramp that gets assigned, and what it shows is basically how the elevation values vary over this region, and you can clearly see a drop in the elevation values right over here if you refer back to the original elevation values from this color ramp. Now just for visualization purposes, if I were to go ahead and change this color ramp to be something a bit more interesting, what we can do is we can click right over here, well double click in fact, and under render type, let's go ahead and switch this to single band pseudo color. And from here, you actually have the choice to choose quite a number of different color ramps. And in my case, I'm just going to go with this turbo color ramp, which is basically what has been assigned automatically as soon as I switch to single band pseudo color. And click apply and OK. And from here, you can see how each of these colors have been assigned to different elevation values. And if you refer back to the actual values, you can see that it ranges from basically around negative 0.79 all the way up to about 46.41.6. And these reddish areas basically refer to these high elevations. And if you refer to this blue color area, you can clearly see the extent of this pit, which is shown in these bluish colors. And to make things a bit more interesting and easy, what I'm going to do is I'm also going to create a contour map using this raster. And with a contour map like that, it would be quite easy for us to visualize how this elevation changes, because that's basically what a contour map shows us. Areas with same elevation basically connected together with continuous lines. So to create a contour map from a raster like this, it's actually going to be quite easy. If you head over to processing and select the processing toolbox, from here, we can simply search for contour. And under GDAL, you can see that there's one tool called contour. So the inputs for this are going to be, well, it's going to generate the contours based on this given raster. So it's automatically selected. And something quite important is the contour interval that we have to specify. So by looking at this elevation range, which is varying from negative 0.7 to 41.6, I'm just going to fix a contour interval of about maybe 5 meters. But this is completely up to you, and it'll really depend on your specific case. And we don't really have to save this contour file into a permanent file. So I'm just going to let it create a temporary file. And after that, just go ahead and click run. And you can see how the contour map got generated. I could open up the symbology tab again and maybe change the colors. Instead of letting it be a very light yellow color like this, I'm just going to specify a dark color like this so that the contour lines would be much more apparent for us like this. And in addition to that, if I were to just right click and open up the attributes table of these contours, the newly generated contours shapefile, you'll see that you can see that there are 3 fields or 3 columns, in which this is the one that I'm actually interested in, which shows me the exact elevation values. So in order to bring these elevation values as labels that are tied to each of these different contour lines, what I'm going to do is I'm just going to right click over here and go to properties. And if you switch over to this labels tab, you can go ahead and select single labels from here and specify that you would like to display the labels which are under this ELEV column, which basically refers to the elevation. Do a slight adjustment to the size, and after that click apply and click OK. And now you can clearly see what each of these different contour line is supposed to represent. Now defining the outer boundary of the pit, well, that's something that you have to actually think about. And in this particular case, I'm just going to make use of a 3D representation of this raster to specify sort of the boundary or the outer boundary of my pit. And to do that, I'm going to make use of an external plugin called QGIS 3JS exporter, which is not something that I'm going to discuss in this tutorial because I'm doing this just for the visualization purposes. In case if you guys are not really familiar with using this plugin, you can just follow along because I'm doing this only to sort of visualize so that we could clearly see how this raster looks in a bit of a 3D manner. So once you open up this QGIS 3JS exporter, I can just click right over here to select the pit, and even after I zoom it in, I might not really see how the elevations change just because of the scale. So what I'm going to do is I'm just going to head over to scene settings and change the vertical exaggeration to be about 30. So we are just exaggerating the elevation values vertically so that I would be able to see clearly what sort of a contour line I could use as the outer boundary of the pit. And as you can see, I think we could either use 25 or 30 as the contour line which represents the outer boundary of our pit. And just for the purposes of this tutorial, I'm going to stick with this contour line which corresponds to 25 meters. And I'm going to pick that to be my sort of outer boundary of the pit. And what I'm going to do is I'm going to calculate the volumes that are sort of below the 25 meters elevation. All right, so let's get rid of this 3D view for the time being. Or in addition, if you would like to digitize and create your own boundary in order to specify the outer border of the pit, well, you could simply do that as well. There's nothing that's sort of restricting you in doing that. However, since one of the tasks that we are supposed to do is to specify a base level below which we are going to calculate the volume of this pit, it's essential that we pick that base level that we are looking for, and I think 25 meters would be a good pick in this particular case. And given that we have already established that 25 meters is going to be our base level, the next step is to basically calculate the volume using a tool that's inbuilt, and that's called Raster Surface Volume. You will be able to see under Raster Analysis, Raster Surface Volume tool. Just double click on that. And again, our input layer is going to be this raster. And over here, we have to specify that base level that we discussed about. So I'm going to enter 25 over here. And when it comes to the method, what we are going to do is we are going to count only below the base level. Just stressing the fact again that what we are trying to do over here is to calculate the volume of a pit, which is basically extending downwards from this specified base level. And the results of this exercise is generated as a report. So even though it's optional, what I'm going to do is I'm going to save this report to a file at a known location. So let's browse to my working folder, and I'm going to name this as volume report. And as you can see over here, the file type, it's going to get saved as .html file, which means you're going to use one of your web browsers to basically open that up. So click save, and after that, we can go ahead and run this tool. And you can see that immediately it managed to generate that report right over here. So if I click on this link, you can see right over here the corresponding details, and we have the volume to be 30,310,952 cubic meters. And we also have the pixel count corresponding to that area. And at the same time, we also have the area given in square meters. That's about 3,500,800 square meters. Well, if you wish to do a quick check, what you could do is you could use one of the tools that's available to see whether this calculated area is correct or not. If I were to use this tool right over here, which is this measure area tool, just make sure that you are measuring the area and set the units to be in square meters. And after that, what we can do is we can just roughly draw along this perimeter of this 25 meter contour line. It's not going to be exact, but it's going to give us a rough estimation of the area, and we can compare that against the result that actually got generated and make sure that everything is in order. So if I complete my circuit, you can see that the area that gets recorded right over here is about 3,535,597, which is a pretty close value to this value, I would say. Of course, I'm going to trust this value more than what I did by my hand manually, because this area calculation is going to be much more accurate since the calculation was done automatically. So guys, that's about it. If you would like to maybe export this contour line which corresponds to 25 meters into a separate polygon shapefile, you could actually do that as well, simply by heading over to this polygonize tool, which is under vector geometry. And you can select this contour shapefile. And before we do that, we need to select the corresponding contour line that we would like to export as a polygon. So you can do that by heading over to the attributes table of that particular shapefile, and the one that corresponds to 25 meters is supposed to be this line. So I'm just going to select it like this, and even if I close this window, the selection is going to still remain. And after that, I'm going to open up this polygonize tool again and make sure that my input layer is going to be this contours shapefile. And I'm going to generate, or I'm going to polygonize only the selected features, not all the features that are present in this shapefile. So in this case, if I just go ahead and put the tick right over here, it's just going to polygonize only this selected feature and none of the other polyline features. And let's go ahead and save this to a file as well. I'm going to name this as pit extent. And after that, click run. And now you can see that the extent of the pit gets demarcated beautifully like this by a polygon. And now we can go ahead and deselect all the selections that we have done. And what I could do is I could maybe get rid of the fill color of this and just have the outline, so that it'll be much more clear that what we're trying to demarcate by this polygon boundary is basically what we consider to be the outer extent of this pit. And this calculated volume in cubic meters basically refers to the volume that is contained by this polygon boundary. Now that would be the quick and easy way of doing things. However, in order to make sure that we have arrived at the correct solution, what I'm going to do is I'm also going to perform this volume calculation in a bit of a manual way, which involves a number of different steps. It's nothing complex, but instead of just using one single tool to generate this volume, we're also going to make use of the raster calculator in order to perform a couple of tasks manually. And I'm trying to see whether I could arrive at the same number that we got right over here by following that couple of steps. So let's do that before we head over to the next part, which is calculating the volume of a small hill. So as the very first step, I'm just going to get rid of these unwanted parts of my raster simply by performing a very simple clip operation on this raster by heading over to raster, and from here go to extraction, and I'm going to select clip raster by mask layer, and my input layer is going to be this raster, of course, and my mask layer is going to be this pit extent, because now I'm just going to cut this raster by the extent of this pit and just only going to retain the areas that's going to be relevant for my calculation. I'm also going to select keep resolution of the input raster just to be sure, and after that click run. And now you can see that we have a new raster that got generated, which basically corresponds to the area that we need to calculate the volume for. And in the first instance, you can see that the colors that has been assigned to that doesn't really look that pretty. So I'm just going to deactivate this for the time being and basically head over to the symbology panel again. And from here, select single band pseudo color and just make sure that you have a bit of a color variation like this, so that you would be able to quite easily visualize how this pit looks in this kind of a manner. And now if you just have a look at the elevation values, you can see that still the lowest is going to be negative 0.79 and the highest in this case is going to be 24.9. All of these values are basically supposed to be below 25 meters because that's the elevation value that we identified to be the base level below which our entire pit is going to lie. And if I zoom in just a little bit, now you can actually start seeing the individual pixels. Now if you're really curious about the resolution of this raster, Well, what you could do is you could right click and go to properties. And if you go to information, right over here you can see the pixel size, and it shows that the pixel size is 10 meters by 10 meters. And you could even actually measure it manually if you were to zoom in until you start seeing these individual pixels. And if you head over to this measuring tool and pick measure line, and if you just simply draw a line from one corner of the pixel to the other, you would be able to see that it's roughly about 10 meters, isn't it? So it basically adds up to what we saw under the information of this particular raster. And may I remind you again that what each of these pixels of this raster is showing us is basically the elevation value. And if you're somehow able to make this raster show the volume of each of these pixels instead of elevation, and if you just perform a sum operation over all of those pixels, that should basically give us the total volume as well, isn't it? Let me quickly illustrate that to you graphically as well. So we established the fact that we selected our base level to be 25 meters. And let's assume that we are looking at a cross section of our pit like this. So I'm going to mark this level to be 25 meters. And now just imagine that we are looking at one single pixel which shows maybe a pixel value of about 19 meters. And in this diagram, let's imagine that that pixel looks something like this, where the pixel value is 19 meters, as I said, as an example. So if I were to assume the depth at that particular point to be a value called y, then we can very easily see that the value of that y is going to be the base height that we specified, which was 25 meters minus the pixel value of 19 meters. So if I were to write an expression for that y, it's going to be like this. Y is equal to the specified base height minus the pixel value. And that's going to be 25 minus 19 in this case. And you could perform a similar task to maybe another pixel which shows an elevation value of around 15 meters. And in this case, if you were to assume the depth to be a value of x, then as you can see, that x value is going to be 25 minus 15. And now what if you wanted to convert this depth into a volume? As I showed you guys, we know that each of these pixels are of size 10 meters by 10 meters. So if I were to just multiply this depth by its surface area, it's going to give me the volume. So for an example, if I were to consider the area aspect of each of these grid cells as well, it's going to look something like this, where the surface area is going to be 10 meters by 10 meters. Which means if I were to just take this pixel and multiply its depth, which in this case is 6 meters, by its area, it's going to basically give me the volume of that one single pixel. And if I were to plug in the numbers for this specific example of this y value, so the depth is going to be 25 minus 19, which is 6, and that depth is going to get multiplied by 10 meters by 10 meters. And that's going to give us the volume in cubic meters. So based on that analogy, you can clearly see that if you were to generate a new raster which shows us the individual pixel volumes that's forming this entire pit, we could just simply add them all up in order to just come up with the volume. And to do that, what I'm going to do is I'm going to head over to raster and I'm going to open up the raster calculator. So based on the sample calculation that I showed you guys, if you were to just come up with an expression to calculate the volume, you can imagine that the volume is going to be measured if we were to multiply the depth of each pixel by its area. And when it comes to depth, the way to calculate the depth would be to take the base height, which in our case is going to be 25 meters, and we are going to minus out all the pixel values corresponding to this raster. And after that, what we're supposed to do is basically multiply that by the area, which in this case is going to be 10 multiplied by 10. And of course, I'm going to get rid of this part since I just wrote it to explain to you guys what we are supposed to do. So we are not really supposed to have random nodes in our expression box. And over here, when it comes to base height, again, we need to specify the actual value rather than leaving that to be just BH. So base height is 25, and as soon as we do that, you can see that it immediately recognizes that the expression is a valid expression. And after that, we are going to save this into a new file, and I'm going to call that pit volume, which is going to get saved as a GeoTIFF file, as you can see over here. So now go ahead and click OK. And now if you were to look at these values, you will start seeing a completely different range of values, because now in this raster, what we see is basically, well, each individual pixel is not really showing the depth, but it's showing the volume. So what we could do is maybe just for visualization purposes, we could just again open up the symbology and change the color ramp to be this, apply. And from here, you can basically see how the volume varies. And if you'd like to check the individual pixel values, you could even do something like that by picking this identify features tool. And if you right click on one of these pixels and select that you're referring to this pit volume raster, right over here, you would be able to see the volume value, which is 1961.5 cubic meters. So now each of these pixels are showing the volume values in cubic meters. And it makes sense as well, as you can see, as we go into these deeper areas, we are talking about much larger depths, which means much larger volumes as well. So you can see these areas in dark colors, which basically refers to higher volumes compared to these edges that you can see right over here in these light blue colors. And now all we have to do is, since we have this shapefile of this pit extent, which we generated just a couple of steps ago, if I were to deactivate both of these, you could see this shapefile, which we have right over here. And since we have such a shapefile as our boundary, what we could do is we could simply do a zonal statistics operation on this. And you could get to that tool by searching for zonal statistics over here. And under Raster Analysis, you could see the zonal statistics tool right over here. Click on that, and now your input layer is going to be this pit extent shapefile, and the corresponding raster layer is going to be this pit volume layer. And something quite important right over here. Now, which statistic are we going to calculate? So definitely what we need to do is we need to sum up the value of all of these pixels that are sort of bounded by this shapefile. So we definitely need to have sum right over here selected. And additionally, if you would like to see how many pixels got added up together, you could even select this count. And things like mean wouldn't really make any sense for us to have in this particular case. And as you can see, there are so many different statistics that you can actually select. But in this particular case, since we are trying to sort of sum up all these volume pixels in order to obtain the total volume of the pit, this sum statistic is basically what I'm after. I'm just going to leave this count ticked on as well, just out of interest. Well, after that, click OK and just click Run over here. And right over here, you can see that it generated a new polygon called zonal statistics. Right click, and if you were to inspect the attributes table, now you could see the sum, which means how many pixels got added up together in order to arrive at this value, which is the summation of all the pixels, of all the volume pixels, which happens to be 30,310,878. Now, if I were to sort of compare this value with the value that we had from this surface volume report, Right over here, you can see that it says the pixel count was 35,008, and in this case, the pixel count was 34,973. If you were to actually compare the volumes, you can see that there's no drastic difference between the values, where this one shows 30,310,878 cubic meters. Over here, it shows 30,310,952. So it's basically pretty much there. And both of these values are in cubic meters. So guys, with that, I think you got the basic idea of calculating the volume of this kind of a pit using QGIS, and you could basically use the same steps in order to calculate the volume of basically anything. It doesn't necessarily have to be a pit. If you're talking about maybe an elevation that's sort of popping above the ground, and if you'd like to calculate the volume of that mass, instead of doing it below a certain base height, you could do that as well. And that's exactly what I'm going to do next, since I have another file called this hill. If I were to drag that and drop it over here, and let's zoom into that. So right over here, if you were to look at this elevation values, you can see that we have these lowest elevations to be 31.3 and the highest to be about 88 meters over here. So if I were to draw, or if I were to generate the contour lines by heading over to this contour tool, and in this case, I'm just going to specify the interval to be about 5 meters. And let's run this. And if I were to check the contour value of this line, I could simply pick this identify features tool, come back to this line and right click and make sure that I'm selecting contour. And right over here, you can read the value to be 45 meters. And in this case, if I were to calculate the volume of the mass that's sort of sticking above a base height of 45 meters, what I could do is I could simply open up this raster surface volume tool and input my raster, which is going to be this hill. And in this case, the base level is going to be this 45 meters. And now what it's going to do, it's going to calculate basically everything above the base level, as I'm going to select right over here. And let's save that report to a permanent file as well. I'm going to name it as hill volume report. Save and then run. And right over here, you can see that volume report. And as you can see over here, this is the volume of that particular hill. Before I wrap up the tutorial, if I were to quickly show you guys in a bit of a 3D manner what I refer to by the hill volume, well, let's quickly go ahead and change the color ramp to be something a bit more interesting. Just going to head over to this catalog and pick something from this topography selection, maybe something like this, and click OK. And after that, I'm going to open up that plugin that I was talking about, which you guys don't really have to bother about in this particular tutorial. As you can see over here, the elevation line that I selected to be 45 is basically this contour line. So what we calculate is basically the volume of this landmass above that contour line. And I hope that it's clear for you guys by now. So with that, we are going to wrap up this tutorial. If you do have any questions about the steps that we followed in this tutorial, add a comment down below and I'll get back to you as soon as possible. If not, you can always show your support by hitting that like button. And if you'd like to stay tuned for interesting GIS related tutorials like this, don't forget to subscribe to this channel as well. I'll catch you guys again with another tutorial soon.